Hi guys, this is me Kong again from POSH coaching classes. Today I am back again with another chapter, that is chapter for class 10th, and the name of the chapter is circles. It is chapter 9 of your textbook. So we will finish the first exercise today, and there is one more exercise that we will finish in our next video. So please do watch the video till the end. There are many things that you need to know, so this exercise will help you in that. So the chapter is circles. Before we go into the exercise, we should know two things. First thing, a circle has no edge, right? So there is no edge in the circle, and there are two lines that we should understand. A line which touches the circle at just one point is known as tangent, and if there is a line which touches the circle at two distinct points, for example, I have an A here and a B, this is known as secant. Okay, this is very, very important that you need to remember. So the line which touches the circle at just one point is a tangent, and then if we have another line which touches the circle at two distinct points, it's known as a secant. All right, so now we will just go through few more things before we start the chapter. You need to remember that if there is a circle, this circle, and if there is a line touching the circle at just one point, as I just said, it is known as tangent. Now obviously if we have a circle, there has to be a center. So if the center is O, if there is a line which touches that point where this tangent is touching the circle, this will always be 90 degree. So you need to remember this. The line from the center touching the tangent, it will always be 90 degree. So this is one more thing that you need to remember, right? I hope this is clear, guys. So let's go ahead and start the exercise. So the exercise for today is exercise number 9.1, and the first question it says is, how many tangents can a circle have? So I just told you about the circle. So if I have a circle, for example, this is the circle. Now it says how many tangents this circle can have. So the answer for question number 1 will be infinite number of tangents. Why? Because this circle, I can put tangent at any point. If this is the circle, I can put a tangent here, I can put a tangent here, any point. These are all the points. So every point will have its own tangent. So if I have n number of points in this particular circle, I can have infinite number of tangents. So that's the answer for your first question. Now the second question is fill in the blanks. It's very important, fill in the blanks. You may see these fill in the blanks in your exam as well. So let's see, what does it say? The first fill in the blank says a tangent to a circle. I'll write it here. A tangent to a circle intersects it in dash points. So if we can just remember what I said in the beginning of this video, a tangent to a circle intersects it in one point, because as I told you just now, if there is a circle, it will just touch the circle. The tangent will touch the circle at just one point. So the answer is 1. Okay. Let's see the second one. Now it says a line intersecting a circle. A line intersecting a circle in 2 points is called dash. Okay guys, so the second one is a line intersecting a circle in 2 points is called, this is what I just discussed in the beginning, is called a secant. I told you a line touching circle at 2 distinct points is known as a secant. Let's see the third one. The third one says a circle can have dash parallel tangents. A circle can have dash parallel tangents at the most. Okay, so now I have a circle. It says then how many parallel tangents can I have? If I have a tangent here, I can have another tangent parallel to this tangent, so I can have 2 tangents parallel at the most. Okay guys, let's see fourth. Now the fourth one says the common point of a tangent, the common point of a tangent to a circle and the circle is called, to a circle and the circle is called dash. The common point of a tangent to a circle and the circle is called, this is known as point of contact. Okay guys, wherever the circle and the tangent will meet or touch each other is known as point of contact. I hope this is clear guys. So this finishes question number 2 of this exercise. Let's move on to question number 3. We just have 2 exercises in this particular chapter, so today we are going to finish the first one. So let's go to the next question. Now the next question here, it says question number 3. So the third question of this particular exercise is, it says a tangent PQ at a point P of a circle of radius 5 centimeter. So first of all, I have a circle and the radius of this circle is 5 centimeter. Now what does it say? Meets a line through the center O at a point Q. So I have a radius that is 5 centimeter and this point is P. I have another point Q here. Okay, so this point O meets this point Q, which is outside, and the distance between O and Q is 12 centimeter. Okay, now what does it say? We have to find the length of PQ. So this length has to be, we have to just check what is the value of this PQ. So what are we going to do? I told you just now, I'll write, since we know that the tangent and the line drawn from the center of the circle are perpendicular to each other. So this line and the tangent, they are perpendicular to each other, so obviously this will be a right angle. So now therefore angle P is a right angled right angle. So therefore in triangle OPQ, right angled at P, what we are going to use? We are going to use Pythagoras Theorem, PGT, which is hypotenuse square is equal to base square and plus perpendicular square. So in this case, I have OQ as hypotenuse, OP as base, and we are about to find PQ, that is perpendicular. So let me go this side. So hypotenuse is 12 centimeter square. Then I have base, that is 5 centimeter square. And PQ, I need to find that PQ. So 12 multiplied by 12 is 144 centimeter square. 5 multiplied by 5 is 25 centimeter square. And PQ square will be as it is. Or I'll take this, I'll write it first, 25 centimeter square plus PQ square is equal to 144 centimeter square. Let me keep PQ square here and take 25 to the other side. So this is 144 minus 25. PQ square is equal to, if I take 25 out of 144, so this is 9, then we have 13, this is 3, 1, 1. So PQ square is equal to 119, but PQ is equal to, square goes that side, it is under root 119. So we have been given 4 options. So let's see if we have one of those options. Yes, D part is the answer, because D part says under root 119. So that is your question number 3. So let us see now what is question number 4. Now the question number 4, you may need your geometry box, because you may need your protractor, compass and the ruler as well. Alright guys, so we have question number 4, and it says draw a circle and 2 lines parallel to the given line such that one is tangent and the other one is a secant. So what is given? We have a circle. This is the circle. So obviously we have the center of the circle, and there is one more line given. Let's take this as the line. Let it be L. And now this line is given, this circle is given. Now we have to make 2 lines, we have to draw 2 lines in such a way that one is tangent and the other one is secant. So what are we going to do? You can take your compass and then keep it here at the center O and drag it more than this line. So once you are out of the line, you make one semicircle kind of a thing here, and then from this point keep the tip of the compass here, draw an arc, and same way on this tip draw another arc, and then just join these 2 lines, these 2 points. Okay guys, so once you are done with this, you will get to know that this is the point on the circle where this radius of the circle is meeting, and we know it that a tangent drawn to the circle is always 90 degrees. So here, now taking this particular line, you can make an angle of 90 degree. You know how to make it, and then draw a line. So this is the tangent what we are talking about. Let it be M. So this was the line given, this was the circle which was given, this is the tangent what we have actually made, and now we have to make a secant, and we know what the secant is. Secant is which touches the circle at 2 points. Take any point on this particular line and again make an angle of 90 degree, and then draw this line, and same way draw a line this side as well. So this particular line will touch the circle at 2 different points. Clear guys? So let me write the steps of construction as well. Steps of construction. So first of all, what we did, we took the compass. Using compass, draw an arc, let it be x and y, x, y. Okay, taking x as center, draw an arc. Then taking y as center, draw another arc intersecting the arc of step second. This is the step second at, let it be n. We have taken n? No, n, at n. Okay, then what we did, we joined n and o. Join ON intersecting the circle at point, let this point be M, capital M. Okay, then what we did, taking M as center, draw, let's draw an angle of 90 degree. That's what we did. So then we took another point P, taking P as center, draw an angle of 90 degree, touching the circle at two distinct points A and B, right? So therefore M is the required tangent and AB is the required secant. Got it, guys? So this is the figure that you need to make, and a very important question, by the way. So this figure, and then this is the steps, these are the steps of construction which you have to write when this particular question comes in your exam. So this is question number 4, and this is the end of the exercise as well. So this finishes our first exercise of the chapter circles, that is chapter 9. Please do watch and make a note of these questions as well. In case if you have any doubts, please do ask me. You can comment me down below, and you can just leave a comment so that I can let you know about any doubts which you have. Please do share and subscribe to our channel as well. Thank you so much. This is me saying bye bye to you. So we will see you in the next one. Take care.